All right, so 1, 2, 3, here we go. All right, so today we're going to look at how we create a plan for attacking the science portion of the ACT. Now, I'm going to relate it back to the reading portion and how we looked at and took advantage of the fact that they're giving us a writing excerpt that is well written. The science, it's all about information. Now, it's not a typical way that we get information. It's not necessarily about what do I know about molecular, submolecular particles or anything like that. That's not necessarily what it's about. It's about how can I quickly process the information on this given subtest. Now, within the science, in my opinion, there's really two parts. Now, others may break it down into smaller parts and things like that. You have the portion that is a hypothesis. All right, basically you're going to get hypothesis A, hypothesis B, and hypothesis C. So you got three arguments going on over some scientific concept. We'll talk about that different probably tomorrow than today, okay? Because that one's a little bit different in the way to approach it. But for today, we're going to look at the other sections, which usually there's 3 or 4 of those, and they are all about how do I process information and get to and from the questions and answers. So if you remember back to the reading, we gave you a structure for that. All right, on the science, let's say they're going to give us 3 different pieces of information. This one called Figure 1. This one called Figure 2. And then maybe we got a pie chart or a pie graph that looks like this, and it says Graph 1. It may say Figure 3, whatever it says. But this is their chosen method of imparting information to us. Now, we want to think about this the same way we do in the reading from a standpoint of, okay, I don't have to know every single thing about this. But if I can know what information is contained in Figure 1, what information is contained in Figure 2, what information is contained in Figure 3 or Graph 1 or whatever it's called, all right, that's most important because then I can focus my energies and my attention to questions over here. Okay, now the great thing about the science, for about half the questions, they will actually, as a lead into the questions, they will say, in Figure 2, blah, 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 blah. Okay, but we'll get to that in a minute. Let me teach you a little bit how to process the information. Okay, first thing I'm going to do when I look at a science, a subtest on the science, I'm going to try to figure out how many different graphs there are. How many different figures there are. It's pretty simple. 1, 2, 3. Typically, they're going to give you 2 or 3. Maybe there'll be an exception and they give you a 4th. Okay? I'm going to look for a title. Okay? If you had any of our science teachers here, when you had to create a graph in whether it's physical science or physics or chemistry, you're supposed to be putting a title on the graph, right? Yeah, we're supposed to put a title. So I'm going to look for a title, okay, on one of these. They may be there, they may not. But that title is going to give me some basic information. Now, it only takes me maybe 6 seconds, 7 seconds to look at the 3 titles. And very often, they're going to be related to one another. All right? Once I see that they're related, then I want to ask myself, what are the differences between Figure 1 and Figure 2? Okay? Now, little throwback here to freshman level graphing. All right? On the x-axis, remember we have an independent variable. Okay? Very often that is time or time related. Not always, but most often it's time related. For instance, if I was going to take an evaluation of the amount of time it takes for this marker to hit the floor, 1,000, 1,000, like 1.2 seconds or whatever it was. Okay? At time is 0, we could look at the height, okay? And at time 1, it's gone down. Y'all remember seeing graphs like that, right? All right, we can evaluate very quickly what that graph is talking about. Now, I may not know all the little bitty minuteness in it, but I can at least know the general idea of what that's all about. Now, a couple things to look for. So we got title, we got independent. The y-axis is typically the dependent variable. Okay, like right here we were talking about height. That was the dependent variable is dependent upon how long, how much time it elapsed. So those things start to give us, well, one of y'all, Anna, will you go, or one of y'all just turn that off, they know where I'm at. Take that smaller, and just, yeah, thank you very much. All right, so I want to look at it from a standpoint of figure 1, 20 to 25 seconds. Okay, I'm going to figure this out. You just look it over, see what's going on in there. Is there a comparison? Do we have 2 or 3 things being graphed and compared with one another? Is there a time? Is there a normal breakdown? I mean, there's all sorts of things that we're going to look at within this. And I know it sounds like I'm shoving a lot at you. If we have time today, I'll give you an example of how I would go through this. Okay? The second one, 20 to 25 seconds. Just look through it. See what I can figure out. And as you practice this, you're going to get a lot better at it. All right? Instead of taking 25 seconds, you're going to be able to do it in 15 seconds. Now, the third one, same type of thing, 20 to 25. But let's talk about circle graphs real quick. Does anybody remember studying circle graphs either in science or math and what they are most often used for? Percentages, absolutely. We'll have percentages in here very often. Now, some things you need to recognize. A diameter all the way across is what percent of the circle? 50%. Okay? It's 1/2 the circle or 50%. If for some reason that is cut in half, this is a 25%. Now, this is just information for this specific type. Okay? These are just type, things that you might just need to chalk up in your memory as you're thinking about the science. Now again, why am I doing this? I'm doing this to gather this information to say, okay, where do I find the answer to number 1? Where do I find the answer to number 2? Okay, if number 1 says in figure 1, then I'm going to forget about 2 and 3. Or it may say something like, compare between figure 2 and figure 3. Do I worry about 1? No. Okay? One of the things that students tend to try to do, that they get some bogged down time-wise, they try to know every single little thing about all these graphs. Everything. No. Make yourself familiar with it. Know what information is contained therein. That is the most important thing. All right? Now, there's one little thing that's missing here in discussions about these figures and everything like that. That is a key. Very often these charts or graphs are going to have a key there. For instance, it may say solid line is the days that are above 70 degrees. Dotted line is days that are below 70 degrees, or whatever it would be. Okay? Notice the key. It's often in a little box off to the side or in a smaller portion of that graph. Notice the key because it helps us differentiate in information. Questions so far? Anybody? All right. Can you see how I'm relating this to the reading? Reading, we're gathering information that's written, okay, in paragraph form. Science, I'm gathering information that's given to me in a graph, in a chart, not necessarily the typical way that we process information, but it's about how quickly we can process it. Now, they typically have a paragraph that's also related to it in some way, shape, or form. Most often when I do the practice tests for science, I don't even read the paragraph, or I'll give it a very, very quick look. Okay? More often than not, they're referring back to these graphs than to what's in that paragraph. Now, if I don't quite understand everything going on here through the figures and the graphs, all right, I may take a moment, read the first couple lines of the paragraph. Are they trying to tell me anything different, or is this just scientific fluff? It may just be scientific fluff. It may have nothing at all to do with the questions at all. Okay? So heads up on that. All right. So let's talk about how we practice for the science. So if I'm going to set up a practice schedule for this science, I got 28 days until the test. I'm going to shoot to get 4 practices in. Okay? Let's say I do the 21st. That's today. Okay? So tonight, I'm going to give myself a goal of graphs, charts. Okay, the goal is going to be 1:45. Minute and 45 seconds. So that's going to leave me 6:15 left to concentrate on the questions. Now, the questions are a little bit more difficult than the reading questions, okay, because they are science-based, bigger words, a little bit more academic, if you will, from a science standpoint, okay? Keep time. Keep time. If you're able to do this in 1:37, next time, that's your goal. Try to get a little bit quicker. And what you're doing is you're buying yourself more time for the questions and the answers. Does everybody understand how that concept works? Everybody follow me on that? First time I practice it, here's my beginning place. Second time, I want that time to be brought down low. And in doing that, what you're doing is you're conditioning your mind, you're conditioning your body to have an internal clock that says, okay, we're starting to get toward that time frame. Now, go ahead and stop it at this point, Jane.